Hello, today we are going to talk about electricity. So, electricity is the form of energy that results from the existence of charged particles. You obviously know how electricity helps you in your life. What is charge? Charge is a property of matter due to which it experiences and produces electrical and magnetic effects. Now, let's look at the media of charge. There are two media of charge. Charge is carried through charged particles of matter. The first charged particles are positively charged particles carried by protons, and the negative charges are carried by electrons. And the SI unit for charge is coulomb. What are the properties of charge? Well, number one, the first property of charge is quantization of charge. It says that the net charge on a body is a multiple of the smallest value of charge, which is 1.6 times 10 to the minus 19 coulombs. That is the charge on one electron and one proton. Well, you can't have half an electron. So if it is not a multiple of that charge, um, the smallest value of charge, it cannot exist. The value of charge cannot exist. So that is the quantization of charge. Moving on to conservation of charge, which says that charge can neither be created nor destroyed. It can only be transferred from one body to another. It's basically like matter and energy. It cannot be created or destroyed. That is the conservation of charge. Moving on to the fact that unlike charges attract each other, like you already know, positive charges and negative charges, they attract each other. Um, Positively charged atoms and electrons attract each other, and that's how charges move. Moving on to the additivity of charge, which says that the net charge on a body in an isolated system is the sum of all the charges in that system, in that body. Let's say an object has 16 charged particles. All you need to do is add 1.6 times 10 to the 19, 16 times. Basically, you multiply the smallest unit of charge by 16, by the number of charged particles in an isolated system. That is how you find the net charge of a body. Q equals N times E. Now the next point, charge is a scalar quantity. It does not change by direction. It does not depend on direction. Moving on to Coulomb's law. Now the electrical force between two charges is directly proportional to the product of two charges, which means that F is directly proportional to Q1 multiplied by Q2. And at the same time, this electric force is inversely proportional to the square of the distance between them. Basically, it's F is proportional to 1 upon r squared, or F is inversely proportional to r squared. Keeping that in mind, we get the formula F equals kq1 q2 upon r squared. Since q1 and q2 are directly proportional to the force and r squared is inversely proportional, we add a constant called k, which stands for 9 times 10 to the power of 9 Newton meters squared upon Coulomb squared, and we multiply this by the fraction. Moving on to insulators and conductors. The substances that do not allow current to flow through them are called insulators. Examples are plastic, paper, styrofoam, etc. You can't make current flow through styrofoam, right? The substances that allow current to flow through them are called conductors. Examples are copper, gold, silver, etc. Sorry for the bad spelling there. You might have heard about electric current. What is it exactly? Now let me tell you, electric current is the rate of flow of charge. It is the amount of charge that flows through one point in a closed circuit in 1 unit time. You can denote it by the equation I equals Q upon T. Now moving on to the SI unit of charge, which is ampere. You denote it by the sign A. Now what is electric potential exactly? So electric potential is the work done in bringing a unit positive charge from infinity to that point. Voltage is the other name for electric potential. V equals W upon Q. It's the work done upon charge. Now what is potential difference exactly? Potential difference is the amount of work required to be done in moving a unit positive charge from one point to another point. Potential difference at one point minus the potential difference at the other point is equal to the work done in moving the charge between the 2 points upon the charge moved. So let's learn about how charge is actually flowed between 2 points. To do this, let me just show you a video. Now let's make two spheres, sphere A and sphere B. Let's make them quick. Yeah, let's label the first one A and the other one B. Sphere A is positively charged. Let's put that in. Yeah, let's just surround it with positive charges. And sphere B is negatively charged. Let's use another color here. Yeah, there we go. Putting it in. Let's make stands underneath them actually. This looks pretty neat. In the next one I need to use a ruler. Since we actually experiment with positive charges, we are going to use a positive charge in this diagram too, because the potential difference is the work done in moving a positive charge from one point to another. So when we bring a positive charge in the middle, it is attracted towards the negative side due to property of charge, and it is repelled from the other positive charges, as we can already see. So when we move it towards the positive charge, we'll have to do more work onto the positive charge, right? Because it is getting towards the negative charges anyway. So we need to do more work to move it to the positive charges compared to the negative charges. And since work is directly proportional to the potential difference, sphere A would have a higher potential. And the potential on sphere A would be greater than the potential on sphere B. So sphere B would be of high potential. Let me just write it in. And at the same time, sphere B would be of lower potential. I'm sorry for my bad handwriting. Yeah, I'm trying to improve it. So now that we know that opposite charges attract, positive charges would move towards a lower potential and negative charges would try to move towards the positive potential. And when we connect a wire between the two spheres, electrons are going to move from the lower potential to the higher potential because electrons have more mobility than the positively charged atoms. Protons cannot just move out of atoms, right? Electrons have greater mobility. So electrons are going to move from the lower potential to the higher potential. Thus, potential difference is a concept that causes electricity to flow. The electrons are going to keep on flowing until the balance of charges between the two spheres is equal. We need more potential difference to cause the charges to flow. In the next part, we are going to be discussing resistance and resistivity, the heating effects of electric current, and we're going to be discussing how to draw circuit diagrams. For this part, thank you so much for watching this video. Drop a like if you really enjoyed this video or learned something new from it. Make sure you subscribe to this channel, and I will keep on making more videos for you guys. Thank you.